Okay, hello everyone. Today we're going to talk about parabolas. We're going to do a little bit of graphing. We're going to talk about the directrix, the focus. So it'll be a little different parabola than what you're used to. Speaking of what we're used to, let's do a quick review. We're used to seeing the function parabola, y equals x squared. Maybe once in a while we see the reflection and we graph y equals negative x squared. Today we're actually going to look at a few others. We will look at x equals y squared. Notice both these terms are positive. It's going to open up in a positive direction. If we were to solve this equation for y, we would get a positive square root of x and a negative square root of x. Or we might get just the opposite. We might have x equals negative y squared, and then it would open up in the opposite direction. Most of them we're going to work with today are going to have a vertex at 0, 0. So the new equation has the form of y equals x squared over 4p, but you'll have to solve it, get x squared by itself. X squared equals 4p times y, and that's the form that we'll find most helpful today. Now, if our vertex is something other than 0, 0, this may look a little familiar. We will add our h and our k. Y minus k equals 1 over 4p x minus h, quantity squared, where we get the horizontal shift and the vertical shift. Now, if it's a non-function parabola, we're dealing with the y squared. So our equation would be x equals y squared over 4p. Again, let's try solving this for y squared. And we'll get y squared equals 4p times x. If we have a non-0, 0 vertex, then this equation will look like x minus h, again keeping the horizontal shift with the x term, equals 1 over 4p times the quantity y minus k squared. Okay. Thank you. All right, so the next thing you want to look at, we're going to bring the focus into it. Yesterday when we looked at ellipses, we had a focus, and our parabola is also going to have a focus. And the focus is going to be somewhere inside here, just like we saw a minute ago. And if we have a vertex at over h up k, this focus is still going to have the same x value. So we're going to let h represent that. And then we're going to have a distance here of p. So our y value is going to be whatever k is plus p. Now we also have something called a directrix, and this may or may not be new to you, but we take that p distance and we go in the opposite direction, still on this perpendicular line, and we sketch a line down here called the directrix. This one would happen to be, it'll be a y equals equation, and in this case, it would be y equals k minus that distance of p. Okay, so let's look at our first example. We want to find the focus and the directrix for y squared equals 12x with a vertex at 0, 0. Okay, so our normal y squared equation is right up here. Y squared equals 4p times x. So it looks very familiar. It's already in the format we want. In order to solve for p, we can just set 4p equal to 12. And we know that p equals 3. Once I have that distance, this should be pretty easy to graph. I know a positive y squared, and I have to look at both sides of the equation to make sure this is really a positive y squared, will open to the right. I know it's a non-function. I also know that my center, my vertex is 0, 0. This p gives me my focus, which will be over here at 3, 0. Again, I'm opening up to the right, and then I have a directrix at 3 units in the other direction, because those both have a distance of 3. So my directrix has an equation of x equals negative 3. Okay, next example. 0, 0, x squared equals negative 4y. Okay, well, let's solve for p and see if we can graph it. I have a negative x squared here. Even though the negative's over here, if I were to solve this equation for y, I would be dividing, not subtracting or adding, but dividing by a negative 4. So that would make my x squared go negative. So I'm going to be graphing something that's reflected over the x-axis. Now it's still in another good format. I am used to x squared equals 4py. So I can just take my 4p, set it equal to negative 4, and I know p is going to equal negative 1. Okay, so I have my vertex. I have my distance of negative 1, or 1. This new ordered pair would be 0, negative 1. I can sketch my graph, and then I need my directrix. If I go 1 unit down, I'll be going 1 unit up. So my directrix on this perpendicular line right here is going to be y equals 1, and my focus is going to be at 0, negative 1. Sorry, part of that was off the screen. Okay, number 3. Vertex 0, 0, y equals negative 1/2 x squared. I know the negative x squared is going to be upside down or reflecting over the x-axis. It's in the format I like it, but it's a fraction, but let's just try to solve it out and see how it goes. So I'm going to have 4p, it's not in the format I want it in. I need to get x squared by itself. So I need to multiply both sides by negative 12. Sorry about that, just trying to jump ahead a little bit. Over here, the negative 12 will cancel out the 112. I'll have negative 12y on the left-hand side equals x squared. Now I have it in my x squared equals 4py format. So I will take 4p, set it equal to negative 12, divide both sides by 4, p equals a negative 3. Now again, your graph is upside down. It has a vertex of 0, 0. P will be 3 units down, so my new focus, my focus is going to be 0, negative 3. So I just kind of went around the ordered pair there. Directrix is 3 units in the other direction. Equation will be y equals 3. Now let's write the word focus here. Okay, lastly, given the information of the vertex and the focus, find the equation and graph it. Okay, well, let's start by seeing how far we can get with a graph. Go ahead and plot 0, 0. And if you have a focus of 5, 0, 1, 2, 3, 4, 5, that tells you a lot about your parabola. That means your parabola is going to be opening up to the right. Then you ask yourself, do I need an x squared equation or a y squared equation? We should pretty easily be able to identify this as a y squared type equation. So the form we've been using today is y squared equals 4px. I have p this time. I know that p is 5. So I can put into this equation y squared equals 4 times 5 times x. Y squared will equal 20x. And that's really all you have to do. They may ask us to go the extra mile, 1, 2, 3, 4, 5. Sketch in your directrix, and your directrix here would be at x equals negative 5. All right, last one. Again, I would start out by graphing. Now this time they're giving me the directrix. I know I have the directrix at y equals negative 2. So this is what y equals negative 2 looks like. That should be a review. So now I know my focus is going to be up here at a positive 2. And that'll tell me my parabola is going to open up. Now that's my typical x squared type graph that I'm familiar with. So my new standard form of this equation is x squared equals 4py. And then I just realized, or I've been using a distance of 2 for your p value. So just plug in 2 for p. 4 times 2 times y, and simplify it. Okay, good luck on your homework.